Go to a mirror. Look at the person staring back at you. You recognize the face. You know the history behind those eyes. You assume that you are unique, that your life is a singular story that has never happened before and will never happen again. But what if that reflection isn't just light bouncing off glass? What if it is a window? Physics suggests that somewhere out there, far beyond the reach of our telescopes, there is another you. A version of you that made different choices. A version that took the job you refused. A version that didn't make the mistake that keeps you up at night. Or perhaps a version that is reading this right now, wondering about you. To find them, we have to look at the limits of our vision. We live in a bubble called the observable universe. It is a sphere of light, roughly 93 billion light-years across. The edge of this sphere is not the end of the universe. It is simply the end of time. The light from beyond this line hasn't had enough time to reach us since the Big Bang. No scientist believes the universe stops at the edge of our vision. It is like standing on a ship in the middle of the ocean. You can only see the horizon, but you know the water continues beyond it. The question is, how far does the water go? Most models suggest it goes on forever. If the universe is truly infinite, we run into a strange logical problem. We call it the level 1 multiverse. Imagine a quilt. Our observable universe is just one square patch on that quilt. If the quilt is infinite and matter is distributed roughly evenly, then eventually the patterns must repeat. Infinity is a big number. It is big enough that anything that can happen will happen. And not just once. It will happen an infinite number of times. This is not magic, it is math. Think of it as the Lego theory. Your body is made of atoms. There are a lot of them, but the number is finite. There are only so many ways you can arrange protons and electrons within the volume of a human being. If you have infinite space, eventually nature runs out of unique designs. It has to start reusing the blueprints. Somewhere, the random swirl of cosmic dust must, by sheer statistical necessity, come together to form a solar system exactly like ours, with a planet exactly like Earth and a person exactly like you. So how far away is this other you? Physicists have actually calculated the distance. It is 10 to the power of 10 to the power of 28 meters away. That is a number so large that if you wrote a 0 on every atom in the observable universe, you wouldn't have enough space to write it down. But it is not infinity. It is a specific distance. If you traveled that far in a straight line, you would eventually find a world where you are sitting in this chair, reading these words, wearing the exact same clothes. You are not unique. You are just the local copy. But repetition is just the first level. The second level changes the rules entirely. We used to think the Big Bang was a unique event, a single explosion that created everything. But the theory of eternal inflation suggests otherwise. Imagine the early universe as a pot of boiling water. The water is space expanding at a terrifying rate. Occasionally, a small patch of that water cools down and stops expanding. It forms a stable pocket. That pocket is a universe. Our Big Bang was just one bubble forming in a vast boiling ocean of energy. And the ocean is still boiling. It is creating other bubbles right now. We are floating in a cosmic bubble bath that never ends. This leads to a lonely realization. Cosmologists call this the Swiss cheese model. The cheese is the rapidly inflating void, expanding faster than the speed of light. The holes are the pocket universes like ours where expansion has slowed down enough for stars to form. Because the cheese between the bubbles is expanding faster than light, we can never reach the other bubbles. No signal can travel between them. We are trapped in our own hole, forever cut off from the rest of the multiverse. In the level 1 multiverse, every patch has the same laws of physics. But in the level 2 multiverse, the laws can change. When a bubble forms, the fundamental constants of nature settle randomly, like rolling a dice. In our bubble, the speed of light is roughly 300,000 kilometers per second. In a neighboring bubble, it might be 10 kilometers per hour. In another bubble, gravity might be repulsive, or electrons might be too heavy to orbit protons. Most of these other universes are dead wastelands. They are sterile voids or crushed singularities. We exist because we live in one of the rare, lucky bubbles where the numbers align to allow life. Is this just a theory? Or do we have proof? We might have a scar. When we look at the heat map of the early universe, we see a mysterious anomaly. It is called the cold spot. It is a massive region of the sky that is significantly colder than everything around it. Some physicists believe this is a bruise. Billions of years ago, our bubble might have bumped into a neighboring bubble. Like two balloons pressing against each other, the collision left a permanent mark on the skin of our universe. We might be looking at the fingerprint of another reality. We have looked far away. Now we must look right here. The Level 3 multiverse is not in deep space. It is in this room. It starts with quantum mechanics. Subatomic particles like electrons do not behave like solid objects. They behave like waves. They can be in multiple places at the same time. This is called superposition. But when we measure them, they snap into one position. The question that haunts physicists is why? And more importantly, what happens to the other possibilities that didn't happen? In the 1950s, a physicist named Hugh Everett proposed a radical solution to the quantum mystery. He called it the many worlds interpretation. He argued that the particle doesn't choose a path, it does both. But it can't do both in the same universe. So nature makes space. Every time a quantum event has multiple possible outcomes, the universe splits. In one timeline, the particle went left. In a new parallel timeline, the particle went right. This isn't just a theoretical trick. It means that reality is constantly fracturing. Every nanosecond, you are splitting into infinite versions of yourself. This creates a structure that looks like a tree. Think about the number of atoms in your body. Think about how many times they interact every second. Every single interaction creates a new branch. This is the tree of time. There is a branch where you stopped watching this video 5 minutes ago. There is a branch where you became an astronaut. There is a branch where humanity went extinct in 1962. They are all real. They are all happening right now, but they are separated by a wall of decoherence. We can never see the other branches. This solves the most famous paradox in science. We all know Schrödinger's cat. The thought experiment where a cat in a box is simultaneously dead and alive until you open the lid. That sounds impossible because it is impossible. In the multiverse, the cat is never both. There is one universe where you open the box and find a living cat. There is another universe where you open the box and find a dead cat. There isn't one confused observer. There are two distinct observers living in two distinct asamai. Timelines, each convinced that their outcome was the only one that happened. This leads to the most terrifying thought experiment in physics. Quantum immortality. Imagine you play a game of Russian roulette. In 5 universes, the gun fires and you die. Your consciousness ends, but in the 6th universe, the chamber is empty. You hear a click. You survive. Since you cannot experience being dead, your consciousness only continues in the timeline where you survived. To an outside observer, you die eventually. But from your perspective, you might just keep getting lucky. Forever. You might be trapped in a reality where you are incapable of dying, watching everyone else around you fade away. If that isn't strange enough, we have one final level. The mathematical universe, proposed by cosmologist Max Tegmark. This theory suggests that math isn't just a language we use to describe reality. Reality is math. A circle isn't just a shape, it is a mathematical relationship. Tegmark argues that any structure that can exist mathematically must exist physically. If the equations allow for a universe made entirely of cubes or a universe with 10 time dimensions, it exists. We are just one specific equation in an infinite book of numbers. There is one final map we must look at, and it requires us to think in 11 dimensions. According to string theory, our entire universe might be nothing more than a thin membrane or a brain floating in a much larger, higher dimensional space called the bulk. Think of a loaf of sliced bread. Our universe is just one slice. We are trapped on that slice like ants on a piece of paper. We cannot see the other slices next to us, but they are there, separated by a microscopic distance in a fourth spatial dimension we cannot perceive. Another universe could be hovering just 1 millimeter away from your face right now, but you can never touch it. This theory solves a mystery that has baffled physicists for a century. Why is gravity so weak? Think about it. You can pick up a paper clip with a tiny fridge magnet. That tiny magnet is defeating the gravitational pull of the entire Earth. Why is gravity so much weaker than magnetism? String theory suggests that gravity is weak because it is leaking. Unlike light, which is stuck on our brain, gravity might be able to travel through the bulk. It drips off our slice of bread and falls into the other universes. The gravity we feel is just the leftover trickle that didn't escape. But what happens if the slices touch? Occasionally, these brains drift together. They collide. The energy of that impact is what we call the Big Bang. This suggests the Big Bang wasn't the beginning of time. It was just the latest collision. The universes smashed together, reset, drift apart, and then smashed together again. It is a cosmic heartbeat, an eternal round of applause in the dark. Does this knowledge help us, or does it haunt us? We all live with regret. We all wonder, what if? The multiverse tells us that the what if is real. Somewhere you took that other job. Somewhere you saved that relationship. Somewhere you didn't make that mistake. This can be a heavy burden. It makes you feel like your choices here are meaningless. Or it can be a liberation. It means that every possibility is played out. You don't have to carry the weight of the road not taken, because another version of you is walking down it right now. This changes the definition of who you are. We feel small because we think we are one person trapped in one timeline heading toward one death. But in the multiverse, you are not a solo act. You are a choir. You are a symphony singing every possible note of your life at the same time. The version of you that is suffering is just one low note in a massive, complex harmony. You are not alone. You are infinite.